Printing upscaling, due to its influence on the manufacturing workflow, is an essential point of the project implementation. It defines production steps from the first printability experiments towards manufacturing industrialization. The scale-up workflow might be divided into 3 or 4 main phases. The lab scale phase proves the general printability of single materials and determines initial printing methods, parameters and limitations. This information must be preliminarily validated regarding its feasibility using simple industrial solutions within the lab-to-fab phase. Once the concept has validated, a pre-industrial pilot line might be developed. The line should not include all the printing units, but the most important ones to manufacture a functioning demonstrator. At the end, a fully equipped industrial production line with all necessary pretreatment, printing and post-treatment modules can be constructed and implemented. The lab-scale manufacturing line encompasses one flatbed screen printing machine and some separate post-treatment units, such as an oven and a UV lamp. It also includes numerous pretreatment units, which can improve printability and functionality of the printed layers. It's a good idea to use right here the screens suitable for the next upscaling phases. All the materials considered to be applied within the project, the inks and the substrates, must be tested and evaluated regarding their appropriateness and compatibility. At this point, possible process limitations must be identified and solutions envisaged. In this phase, most of the operations can still be performed manually, without any high level of automation. The positioning accuracy limits are to be transferred into the next phase. A comprehensive experiment planning and the result analysis is the key to the success of further workflow steps. A single-unit rotary screen printing machine is an interim stage on the way to the industrial printing of the demonstrator. One printing unit doesn't allow manufacturing of the entire device yet, but a basic proof of the technological concept is possible at this station. Based on the results of the previously conducted experiments, the major printing technology must be chosen and the printing process on the whole must be figured out. Nonetheless, the number of the applied materials and technological steps must be decreased with a focus on the most suitable and crucial ones. If any pre- or post-treatment units are needed, they must be installed inline and integrated into the process. It's not so bad if any of the production steps contain obstacles or they are not fully clear yet. It's a typical problem at this moment. The printing process is to be adjusted according to the newly discovered circumstances. Since different inks had to be fully tested on sheet substrates during the previous step, the raw substrate and its applicability is bound to be explored during the lab-to-fab phase. The automation level must be gradually increased during the experiments, so that at the end of the stage all necessary data about printing parameters and limitations are available. The production line is bound to be prepared for a large batch printing. Once all materials, methods and parameters are fully determined, a development of the pilot manufacturing line should be started. This line must include all crucial inline units to produce a multi-layer printed demonstrator with a planned productivity, quality and functionality. The pilot line may be just a simplified version of the future industrial line, but it has to be able to finalize the experimental approach. For this purpose, all redundant process steps and materials must be excluded, and the printing and supporting processes must be finally optimized for the industrial application and quantity. A modular industrial printing line is a final stage commercial product which has to be specifically adapted and might need a many-year development and improvement. Elaboration of the line completes the upscaling workflow.